Hi, my name is Sebastian Meyer, and today I would like to tell you something about a topic called gaming simulation. What is it? It's about systems thinking and the actors in the system, so the humans in there. And I will tell you something about why, if you have many humans, a multi-actor system, you also need multi-methods to do research and development. Then I'll tell you exactly what gaming simulation is, and we'll illustrate this with two examples, one about railways in the Netherlands and one about urban development. In the end, I'll tell you a bit more about the future trends that I expect in this domain. So if you think about systems, and if you think about socio-technical systems especially, then there are people involved. And these people, they have a choice in the way they do governance, management, operations of a particular system. And for instance, if you talk about the transportation system, then the individual travelers, of course, have a choice on what they do every day as well. The second view is that of complex adaptive systems. This comprises that there are companies, operators, and all kinds of other stakeholders that we consider to be an adaptive agent. They have all kinds of unpredictable behavior, but also they have all kinds of relations and intertwining. So these relations are dynamic, and this influences their behavior again. All these unpredictable components make that the performance of such a complex adaptive system is better seen as emergent behavior than something that is the direct predictable result of something. What we find is that the research tools in these domains are traditionally monodisciplinary and highly disjoint, meaning that there are people that study within the social sciences the behavior of all these agents. There are people in business study that study the behavior of companies. There are people that analyze all kinds of system dynamics. But connecting this to each other, that's not often done. So what if you think of a complex adaptive system? There are all kinds of actors that have relations to each other, which we could call a social network. And nowadays with Facebook, for instance, everybody knows what a social network is. But there's a theoretical perspective on this as well. Some actors may not belong to a particular social network, but still have influence on others. If we consider technical components, take, for example, again, the transportation system. There we have trains, we have cars, we have roads. These components form a technical network. They have relations with each other as well. Some actors are directly controlling it because they're driving a car or they're putting all kinds of generators at work in an energy network. And then, of course, there are humans that are connected to these components. This is what we call the lower part, the social technical network, where another social network, which might comprise of institutions, of companies, connected to this together forms the complex adaptive system. Now, if you have multiple actors, you also need multiple methods. Why is this? Well, if you have engineers, engineers follow rigid design processes. You can see that they have all kinds of V models, for instance, in systems engineering. There's cognitive uncertainty involved because they don't know certain things. And they try to find a best solution with the best of their available knowledge. To do so, they use what we call hard tools, simulations, models, calculations, a lot of numbers that together make a new, better design. If you follow the logic of managers, they have a different type of working because they follow control cycles. They have yearly or periodically reporting within which they need to get into all kinds of performances. Their uncertainty, therefore, is often on the performance indicators. Does my division perform well? Does the system perform well? And to do so, you see a logic where they find accepted solutions that are reasonable, where some engineers may have some input, but if it sounds logical and they feel that this is a good thing to do, then they will do it. They often use all kinds of mixed tools, project and process management tools, for instance. Now, if you follow the last column, there you have politicians. And politicians, in this case, have coalitions. They need to work together in what we call policy arenas. In these policy arenas, they try to converge to a particular solution. What is very uncertain there is the scope. It might always be that somebody comes along that says, okay, but I also have some kind of input into this particular process. This ends up in what we often call negotiated solutions. The knowledge can be disputed, so we can disagree whether something is actually true, which for engineers is absolutely unreasonable to do. And in this, we use soft tools, participation, image, spinning. I'm sure you all know what your politicians do, and you recognize some of this. If we have all these types of actors together, we need to find solutions in which they can work together on formulating new states of a particular system. And that's where gaming simulation comes in. A gaming simulation session, so that is the play of the game, that mimics the behavior of a real-world system. We try to simulate the real world as good as we can, but not by using computers to simulate everything, to make all the decisions. No, we put real people into the role of a decision maker. And this we combine with computerized simulation models very often. So it's quite a broad range of simulations. It goes from analog, multi-actor, stakeholder exercises to complex 3D, multi-week environments and games in which participants really enact together with computers to simulate something. What technology we use is not really essential. It's driven by the goals of the gaming simulation. However, the methods that lie behind are very similar between all the technologies. It's shared. So if you think of the history of this, you can imagine that wars were practiced, I'm saying here in the 19th and 20th century, but there is actually evidence that even Alexander the Great already used to practice his wars with his soldiers by enhancing in all kinds of role-play type of activities. However, in the 1970s, you see that led by, amongst others, Dick Duke in the US, Gibbs, and also related to the soft systems methodology, a bit more of a UK stream by Checkland and Scholes, you see that the testing of complex systems becomes important, especially in the policy domain, because all of a sudden in the 1970s we were confronted with environmental pollutions, nature conservation, social problems that went beyond the traditional structures that were there, especially before the Second World War. An important one to mention is Martin Schubick, who wrote a book called The Uses and Methods of Gaming, already published in 1975. In the 1980s, you see computer gaming coming up. And at the end of the 90s, this gets into serious applications. You can nowadays quickly divide a class into the different generations by playing the sounds of the different computer games at that era. Some generations will know Paratrooper, some will know Mario Bros, and I'm absolutely sure that the younger generations will be completely steered by the sounds of the games that are coming out right now. What you see is the integration of, on one hand, this policy making, and on the other hand, the computer gaming that's integrating because the technology is there. So if you think of this in a structured way, I put in the middle the session, because for us, the play of the game is the most important thing. The input into such a session is a gaming simulation design that specifies the roles, the rules, objectives, and constraints that you need to be able to play a particular system. What also goes in there is what we call the load. You could say the parameter setting of that particular game, the loading of some variables, as well as the situation. It depends a lot whether I play a game with you in a classroom setting or in your daily practice, or if the consequences of winning a game are passing the course or just having a nice time. The game is inspired by the real world. It should be some kind of a representation of the real world, such as is logical in any simulation. Now, if you look from the top to the bottom, you see that I mentioned an organization here. If, for instance, you want to change an organization, you select participants. These participants become input into a session, you play with them, and afterwards they have a particular experience that you can change into learning or into changed behavior. And with that, for instance, you can change the organization. If you go, however, from the left to the right in this picture, you see that I have qualitative data and quantitative data mentioned here. Getting data out of the play, out of what people do, is a fairly new scientific method in approaching games. We really see them nowadays as experiments. So, and with that, you could say that from the top to the bottom, we're in a design science logic. We evaluate the change of organizations, or we evaluate the learning over the game. Whereas from the left to the right, we are in an analytical science fashion. And in the analytical science fashion, we try to say, and this is the red feedback loop at the bottom here, we try to say something about the real world by using the data generated in the game session. So now you know what gaming simulation is. In the next lecture, I will go into some examples as a continuation of this lecture. For now, bye, and thank you.